All right, so a rider in a 3.7, moving a 3.75 meter radius vertical circle feels negative 1.2 Gs. They feel inverted Gs at the top of the circle. This is fun, right? So at the top of this circle, they are like standing like this, and they feel like they weigh 1.2 times their gravity. So let's just figure this out. So 1G minus what the ride is doing is negative 1.2. Well, let's see. Let's consult the experts here. I'm pretty sure the ride is 2.2, right? Right? It's because 1 minus 2.2 would be negative 1.2, right? So the ride is pulling 2.2 Gs, right? How many Gs do they feel at the bottom? Well, it would be 1G plus the ride, right? So 1 plus 2.2 would be 3.2 Gs is what they'd feel, right? And then what is their tangential velocity? Well, you know what we got to do is we got to figure out, this is the ride in Gs. Let's turn it into meters per second squared, right? So 2.2 times 9.8, right? Because remember, 2.2 Gs literally means 2.2 times 9.8, okay? So 2.2 times 9.8 is 21.56 meters per second squared. And then what is their tangential velocity? We're going to use this formula to find it. Okay, so figure out the G's, right? The ride is what you want to use. That's the thing that you're going to use, right? Figure out the acceleration and then just solve, do maths. 21.56 is v squared divided by, what's our radius? 3.75. It says that up here, right? Okay, so now we're solving for v. I'm going to go 21.56 times 3.75 is, then raise that to the 0.5, and I get 8.99. V is 8.99166 meters per second. There we go, right? Okay, so this is the acceleration in meters per second squared. This is the tangential velocity given the radius, right? So this is the other type of problem you'll have to be able to solve. Is I tell you the g-force at some point in the ride, you figure out what the actual ride is doing. Take what the actual ride is doing, multiply by 9.8, get the meters per second squared, and then it'll be that, or you're going to have to use 4 pi squared r over t squared. That's the other type of thing, right?